All right. So this section, we are going to cover 9.7 and 9.8. They're about complex numbers. Complex numbers. Before, in previous sections, we know for a square root of a negative number, if we see the radicand of the square root is a negative number, we know that's not a real number. Yeah, if it's not a real number, what is it? So today we're gonna learn complex number. Complex number. So if you consider this equation, x squared equals -1. If you consider this equation, x squared equals -1, how do you solve this equation in the real number set? Just think about the left-hand side is a perfect square, right-hand side is a -1. Do we have any solutions in real number set for this equation? Not really. No real number take the power of 2 would give you -1. Okay, so this equation has no solution in real number set. But we really want to solve it. In order to solve it, the mathematician, they expanded the number system. We talk about the number system, right? We start from natural numbers, 1, 2, 3, and so on. Whole numbers include 0, 1, 2, 3, and so on. Integers include 0, plus minus 1, plus minus 2, plus minus 3, and so on. And then we have fractions. We have rational numbers. Rational numbers are any numbers can be written as the quotient of integers, of two integers with denominator non-zero. And then we have irrational number. Rational numbers and irrational numbers together give you real number set. But real number set now is not enough because we can't find a solution for this equation in real number set. Then mathematician, what they did is to expand the solution set to complex number set. Yeah, we're going to expand the real number. We're going to expand the number system. Expand the number system. And let me give you the definition for complex number. Yeah, you can find the notes. Okay, you can find the notes. Yeah. So in order to solve this equation, they bring in a little guy. The little guy is the lowercase letter I. They define I equals the lowercase little I equals principal square root of -1. And call I the imaginary unit. Okay? Yeah, again, this is the definition. Remember, when it comes to definition, we don't ask why, okay? Yeah, we want to solve this equation, but this equation has no solution in real number set. So we're going to bring more stuff to expand the system, number system. The mathematician define the principal square root of -1 as I, and name I the imaginary unit. By doing so, we are able to solve this equation. Yeah, we apply the square root property. We have x equals plus or minus square root of -1. We have talked about square root property before, right? Yeah, go back to your notes to look at what is the square root property. So remember, we just defined root -1 as I, so we have plus minus I. Yeah, now this equation has two solutions. The first solution is I. The second solution is a negative I. They are opposites. Yeah. And of course, we know they are not real numbers, right? Yeah. They are non-real complex number. So now let me give you the definition for a complex number. Yeah, I'm going to write the definition right here. complex number set. Complex number set is a set containing all the complex numbers. The notation for complex number set is the capital fancy C, because C is the initial of a complex. Let's pay attention what's in the set. A plus BI. A and B are real numbers. We talked about those notations as well before, right? The fancy R is a real number. This notation means belong to. A, B are two members in a real number set. I is the imaginary unit. Okay, so let me explain. What does this mean? Complex number set is a set containing all the numbers which could be written in the form of A plus BI. Let's look at A plus BI here in detail. A here is called a real part. A here is called a real part of this complex number. It is a real number. B here is called an imaginary part of this complex number. B is also real number. Yeah, you can pause here and repeat it. Yeah, it is a misunderstanding that B is not a real number, because the name of B is the imaginary part, but B is a real number. Both A and B are real number. Why do we call B the imaginary part? Because B is associated with I. I is the imaginary unit. Okay, any numbers which can be written in that form is a complex number. A here is a real part. A is a real number. B here is called imaginary part. It is the coefficient of I. B is also a real number. I is the imaginary unit. I is not a real number, okay? I is not a real number. Okay, so I'm gonna give you some numbers. You determine are they complex number or not. If they are a complex number, what is the real part? What is the imaginary part? Let me give you some numbers. How about those? Okay, let's start from this one. Is this a complex number? Look at the definition. Let me repeat the definition. Any number which can be written in the form of A plus BI. A and B are real numbers. You can pause here and think and then continue. But I'm gonna answer you that it is a complex number. Real part is 3. Imaginary part is 4. 4 is the coefficient of I. I is the imaginary unit. How about this one? Is this number a complex number? You can pause and think. And I'm going to answer the question. It is. I is a complex number because I can be written as 0 plus 1 times I. Real part is 0. Imaginary part is 1. I is the imaginary unit. What about this one? That one is the same with 1 minus I, right? So real part is 1. Imaginary part is negative 1. Don't get confused because the way I read it. Sometimes the complex number might not be given in a standard form. What is standard form? This is standard form. It's good if you could firstly rewrite that complex number in the standard form. And you know what is A, the real part, what is B, the imaginary part. What about this one? This one is the same with negative half plus pi I. Real part is negative half. Imaginary part is pi. I know pi is irrational, but the pi is also real, so it's fine, it's okay. Pi is the imaginary part. It is the coefficient of imaginary unit I. And what about 10 though? Pause here and think. 10 can be written as 10 plus 0 times I. So yes, 10 is a complex number as well. Or even negative 10, you can think about the same. You can think about it, it's the same thing. 10 is a real part, 0 is the imaginary part. You see what I'm saying? 0 the same, it is a complex number because it can be written as 0 plus 0I. Real part is 0, imaginary part is 0. You see what I'm saying? So what about, let me give you a negative number. What about negative 5? Negative 5 is also a complex number because you can write the number as negative 5 plus 0I, right? So you can tell all the real numbers are complex numbers with the imaginary part 0. Yeah, you can maybe write it down. All the real numbers are also complex numbers. It's just their imaginary parts are 0. Is that clear? So what happened here is real set is a subset of complex number set. Okay? Real number set actually is a complex number set. Sorry. A real number set actually is a subset of a complex number set. You can see we did expand the number system from real number set to complex number set. Okay, now let's play with the little I a little bit. You can see how essential, how important the imaginary unit I here. Let's try see what is that. What is I? I is I, cannot be simplified. What about I square? What about I square? If I is defined as the square root of negative 1, you plug in. The square of square root of negative 1 gives you negative 1. So here we have a very, very important formula. I square equals negative 1. I square equals negative 1. You need to remember at least 2 things about I. That's the first thing. I square is negative 1. Second thing is the definition. I is defined as the principal square root of negative 1. Okay, so about imaginary unit I, at least you need to know the 2 things. Let's continue. What about I cube? Can we write I cube as square times I? We know I square equals what? Negative 1. Negative 1 times I is negative I. So if we want to simplify I cube, we have I cube equals negative I. And what is I to the power of 4th? Could we write I to the power of 4th as square of I square? And what is I square? Again, what is I square? Negative 1. What is square of negative 1? Positive 1. Okay, so here I is I square is negative 1. I cube is negative I to the power of 4th power is 1 positive. And now I'm asking I to the power of 5th, 6 power 7, 8. What is I to the power of 5th? Remember, I to the power of 5th can be written as to the power of 4 and then times I to the power of 4, 1. So we have I, right? And I to the power of 6 is I to the power of 5th multiplied by another I. You can figure out on this. You're gonna figure out this on yourself, okay? Some of you might already see the pattern. I to the power of 6 is negative 1, multiplied by another I. So I to the power of 9 is gonna be I to the 10th power is gonna be negative 1. 11th power is going to be negative I, 12th power is going to be 1, and so on and so on. Do you see the pattern? There's a cycle here, right? I, negative 1, negative I, 1, I, negative 1, negative I, 1, and so on and so on. So if the exponent of I is divisible by 4, that is 1. Okay? Let's figure out one more. It's in my notes, I to the power of 99. Is 99 divisible by 4? No. Then how about 90? Is 98 divisible by 4? No. What about 97? Use your calculator to double check. 97 is not divisible by 4 either. What about 96? You will see 96, yes. 96 is divisible by 4. So let's write I to the power of 99 as I to the power of 96 times I to the power of 3. That is a product rule, a formula you have learned from Algebra 1, Chapter 5, okay? I to the power of 96 times I to the power of 3 equals I to the power of 99. 96 plus 3 equals 99. Okay. What is this one? What is this? I to the power of 99. If the exponent is divisible by 4, that is 1. Do you remember that? Yeah. So I to the power of 96 is just 1. And what about I to the power of third? Negative I. See that? Okay. Next up, very, very important formula. If we know A is positive, then the opposite is gonna be negative, right? Let's say A has to be a real number. Let me explain this by giving you a number. Do you like how about 5? If 5 is a positive, we all know that. What's the opposite of 5? Negative 5, right? Negative 5 is negative, right? Okay. And then we consider square root of negative 5. Before this section, we know square root of negative 5 is non-real. But if it's not real, it must be complex, right? Because we have expanded the number system. Complex number set is gonna be the biggest number set that we deal with. If we go beyond, it's gonna be vectors. So we don't that's gonna be beyond the scope. So all that we learn is gonna be in at the most in the complex number set. So if this is not real, it's gonna be a complex number. If this is a complex number, then it must be able to be written in the form of a plus bi, the standard form, right? How are we gonna do that? How are we gonna do that? This is gonna be a formula. I write it in red. Square root of negative a equals square root of a times I. Okay, very, very important formula. This is the standard form of the complex number. Real part is 0. Imaginary part is square root of a. Because a is a positive, square root of a is going to be a real number. So let's go back square root negative 5. If you apply the formula here, square root of negative 5 equals square root of 5 times I. That is 0 plus square root of 5. So clearly, square root of negative 5 is a non-real complex number with the real part 0, imaginary part root 5. Is that clear? This is a very important formula. How do you rewrite square root of negative 2, let's say? It's going to be root 2i. Square root of negative 7, root 7i. Square root of negative 10, root 10i. Is that doable? It's not that difficult, right? It's pretty simple, basic. You just need to have that formula and knowing how do you apply that formula. Okay? Yeah. So also I want you to write down a sentence. Whenever you see a square root of a negative number, you need to rewrite that number in terms of I right away before doing anything else. Okay? Let me say it again. Whenever you see square root of a negative number, don't do anything else. Right away, rewrite that number in something with I. You see square root of 95, right away, write it as a square root of 5i. Why? Now let me explain. For example, let's consider when you see and then you see square root of 95. First thing to do, rewrite it in terms of I, square root of 5i. Okay. Now you can do whatever you want. It's not whatever you want. I mean, you can apply whatever that you have known from before, all the properties. This is a product. This is a multiplication, right? In the multiplication, we have 4 factors: square root of 20, I, square root of 5, I. We can switch the order of them. We can write square root of 20 and the square root of 5 together, and then the 2 I together. Okay. And what is square root of 20 times square root of 5? Do you remember we have a formula? Let me write this formula. If A is positive, B is positive, root A and root B equals square root AB. Okay, if AB are both positive, then the product of square roots equals the square root of the product. Now we're going to apply that formula here. 20 positive, 5 is positive. We could apply this formula. We have a rule 100. 20 times 5 is 100. What is I times I? I times I is I square. Square root of 100 is 10. I square is what? Negative 1. Do you remember that? I square equals negative 1. Very, very important formula. And you have negative 10. That's the correct result. Oops, crashed again. Give me 1 second, let me fix it. Or whatever. It's just my device is not as good as before. It just crashed very randomly. So it's 10, negative 1, this is negative 10. Okay, that is correct. So my point here is a common mistake here. We see square root of negative 20 times square root of negative 5. By the way, common mistake means this is wrong, okay? Don't do that. Yeah, make sure when you take the note, you have that across written down also. That is incorrect, that is wrong. That's not right. Common mistake here is they apply this formula. They end up with 10. Of course, that's wrong. Because the correct answer is negative 10. Okay, so 10 is incorrect. The reason is because you applied this formula. But you are not supposed to apply that because that formula does not apply here. Why it doesn't apply here? Because this formula is only true if both A and B are positive. But you have a negative 20, negative 5. The radicand is not a positive. So this formula does not apply here. So you cannot do this. You see the 2 cross, it's wrong, right? Yeah, I think I made it very clear. So again, when you see a square root of a negative number, the first thing to do is to rewrite that number in terms of I by applying this formula. Okay, we have more of problems in my notes. You can apply and practice. Let's look at some examples. How about, yeah, let's look at some example. I'm gonna give you, so the focus of today, except the concept of complex number, we also need to learn the operations with complex numbers. We need to know how do we add, how do we subtract, how do we multiply, how do we divide complex numbers. So my example 1 is to show you what does that mean. What does that mean when two complex numbers equal to each other. Okay, so solve for x and y. You have 2x plus 3i equals 18 minus yi plus 3i. By the way, x and y are the only unknown in the equation. I is not unknown. I is a letter, yes, but it is known. It is a complex number. It is the imaginary unit. Of course, you have other method to solve this equation for x and y, but I'm gonna apply the definition. What does that mean when we say? What does that mean when we say two complex numbers are equal to each other? What does it mean when we say two complex numbers equal to each other? Two complex numbers equal to if and only if they have exactly the same real part and exactly the same imaginary part. Okay? Alright, so left we have a complex number. This is the I'm gonna cover, okay? Real part. This is the real part. 2x is the real part. By the way, x and y are both real numbers. The pink one is 3. That's the imaginary part. What about the right side? Yeah, we need more work on the right hand side. If we combine the coefficient of I, we have 3 minus y, or you can write negative 3, the same thing. Okay, let me write this again. So once I combine the right hand side, we see on the right hand side we have a complex number as well. The complex number on the right side has a real part 18. And the complex number on the right hand side has imaginary part 3 minus 1. Imaginary part 3, okay? So you can see by the definition that two complex numbers are equal to each other. We have the corresponding part equal to each other. We have real part equal to part. Yellow equals yellow. We have imaginary part equals imaginary part. Pink equals pink. Okay? So from the first equation, we could have x equals 9. From the second equation, if you solve it, you have y equals 0. You see that? Yeah, the point of this example is to show you what does that mean when two complex numbers are equal to each other. Okay? And example 2. Addition and subtraction. How about let me give you addition, subtraction. I believe if you can do subtraction, you know how to do addition. -7 plus I. This is an example in the notes. Minus parentheses. -3 minus I. So you are looking at a subtraction of two complex numbers. You know, you don't have to make the two complicated. When you add, when you subtract, when you multiply complex numbers, you can just deal with those operations as usual. Whatever the rules in real number set apply here as well. So you don't have to worry about that much. You can just get the result by simplifying this expression. In order to simplify this expression, we need to get rid of the two parentheses, right? The first parenthesis has coefficient 1 here. The second parenthesis actually has coefficient -1. So we're going to distribute -7 plus I. 1 times -3, positive 3. -1 times -I, positive I. And then combine like terms. -7 plus 3, -4. I plus I 2I. Here we go. Is that doable? Is that simple? So you can try my example in notes. You can see whenever you add or subtract two complex numbers, you would end up with a complex number. Okay, you add two complex numbers together, you're gonna get a complex number. You subtract a complex number from the other complex number, you would have the difference gonna be a complex numbers as well. You can see the real part is 94, imaginary part is 2, right? Is that doable? It's pretty simple, right? So that is subtraction. I believe you can do addition. If you know subtraction, you would know addition. Again, I don't mean to just hurry, like rush it. I think you can repeat the video to figure it out. I'm just worried my surface crush again. So example 3, we're gonna do multiplication. I'm gonna give you 2 examples here, okay? Multiply. Multiply 2 complex numbers. Number 1, 4i times 3 minus root 2i. As I said, you can just deal with those expressions as usual. Whatever the properties we have learned in real number set apply here as well. So you can see 5 in this case. You can see 4i as a coefficient of the parentheses. So in order to simplify this expression, we'll operate multiplication when you get rid of the parentheses, right? How do we get rid of the parentheses? We distribute 4i times 3 plus 4i times negative root 2i. Yeah, pay attention. How do I apply parentheses to avoid any possible mistakes? 4i times 3 plus 4i times negative root 2i. Be careful with the sign as well. 4 times 3, 12, 12i. Positive, negative, so negative. 4 times root 2, 4 root 2. I times I squared. You see, I don't rush. You are not supposed to rush here. Take your time. You see, I didn't do square cos 91 in my head and combine several steps in one. I did it one at a time. Positive and negative, determine the sign first. 4 times root 2, 4 root 2 times I square. And I'm gonna apply I square equal 1 in the next step. So we have I square equals 91 here. You see, how do I handle it? I just replace I square with 91, right? And I didn't even do the multiplication here yet. I'm going to do that in the next step. Negative, negative, positive. Positive 4 root 2. You see that? So you multiply two you multiply two complex numbers. The result, the multiplication, the product is a common number as well. In this case, real part, imaginary part. Okay? Number 2. 4 plus 3i. 1 minus I. You're looking at the product of two complex numbers. Okay? For you, that's how we're gonna multiply them out. How do I do for you? Remember, first plus outside times outside plus inside times inside plus last times last, and then fill in those cells. First 4 1, outside 4 negative I, inside 3i 1, last 3i negative I. 4 times 1 is 4. 4 times negative. Remember, always determine the sign first. Positive, negative, negative 4i. Positive, positive, positive 3i. Positive, negative, so negative. Negative 3. I square, again, don't rush. I know you know I square equals negative 1. Hope you know that. 4 minus 4i plus 3i. Copy everything. But yeah, this step, all I do in this step is to replace I square with the negative 1. And I have 4 minus 4i plus 3i, negative, negative, positive. Combine like terms, 4 plus 3, 7. Negative 4 plus 3, negative I. You see that? The result is a number. Real part, imaginary part. What's the imaginary part again? Imaginary part here is a negative 1, okay? Yeah, real part is 7. Imaginary part is a negative 1. Negative 1 is the coefficient of I. Okay, before we go ahead to talk about the division of complex numbers, I want to prove this formula. A plus bi times a minus bi equals a squared plus b squared. Okay, a plus bi and a minus bi are conjugates of each other. Again, we see conjugate again, right? It's simply, you see here is a plus, here is a minus. Then the two complex numbers are conjugates. Be very careful. You might want to write it down this sentence. Two complex numbers are conjugates if they have the same real part and the opposite imaginary part. So how important you be able to identify the real part and the imaginary part. Again, you want to write it down. Let me say that again. Two complex numbers are conjugates of each other if they have the same real part and opposite imaginary part. For example, 3 plus 4i. What's the conjugate? You can pause and think and continue. The conjugate is going to be 3 minus 4i. You see those two complex numbers? They have the same real part, yellow, yellow. They have the opposite imaginary part, pink, pink. Let me challenge you a little. Can you tell me what's the conjugate of I minus 1? Common mistake is to tell me I plus 1. However, no, it's wrong. It's better. You could see I minus 1 is not in a standard form yet. Okay? You'd better to rewrite the complex number in a standard form first. In a standard form first. That is negative 1 plus I. Okay? Then what's the conjugate? The conjugate gonna have the same real part, opposite imaginary part. Do you see that? Yellow, yellow, real part the same. Pink, pink, imaginary part are the opposite. Okay? Yeah. So practice that. Repeat that part. I'm gonna prove this formula. As I said, a plus bi, a minus bi, they are conjugate, right? I'm going to prove you that the product of two complex numbers, if they are conjugates of each other, is a real number. That real number is the sum of the square of the real part and the square of the imaginary part. Let me prove it. A plus bi, a minus bi. I thought the people like George, but and then they told me they like FOIL better. So we're gonna FOIL here. Better. So we're gonna FOIL here. As you know, FOIL stands for first, outside, inside, last. Apply my technique. It's not technique, I mean the routine. Like the way you do FOIL. That could times negative, positive. b squared times 1, b squared. See that? A plus bi times a minus bi equals a squared plus b squared. You need to remember that formula, or at least know where could you find the formula in your note. No, it's not your, because the final is going to be closed book. So you do have to remember that. Okay? And also you need to know how to apply it. I would have this formula in the formula sheet for your formula. So focus on R, yellow, yellow. Opposites. Opposite means they have a formula. The result is a sum of two squares. The first square is the square of the real part. Second square is the square of the imaginary part. You might wonder, you might say, I'm going to put a 4 here or negative 4 here. It doesn't matter. I would say positive 4. Even you put a negative 4 here, you would end up with a 16 as well. So it really doesn't matter. Put a 4, 9. What is 4 square? 16. So that is 25. Is that doable? So that's the concept of conjugates. And all right, example 4. All right, so for division, that is example 3. So division is going to be example 4. Two ways to see this expression. That's a division of two. Said this many times. The fraction bar is a division symbol. Numerator, denominator, that's a division symbol, right? So this is a division. I is in the bottom. In order to simplify this, we need to apply some transformation in order to get rid of I from the denominator. And how are we going to do that? 2 steps. Very similar with earlier. And denominator is the 3 plus 4i. What is the conjugate of 3 plus 4i? Yes, 3 minus 4i. Once you have the conjugate, you're going to, step 2, multiply both top and the bottom by the conjugate. Okay? 3 plus 4i times 3 minus 4i. If you really want to follow your formula, remember, if the two complex numbers in the product are apply, the result is going to be a square of a sum. The product is going to be the sum of two squares, square of real part, square of imaginary part. So you have 25 on the bottom. Numerator, when you have to FOIL, then we have to FOIL. Apply my routine. First, outside, outside, inside, inside, last, last. First, 2, 3. Outside, outside, 2, negative 4i. Inside, inside, negative I, 3. Last, last, negative I, negative 4i. That is negative 4i. I just don't have enough space there. 2 times 3 is 6. 2 times negative 4i, negative 8i. Negative I times 3, negative 3i. Negative, negative, positive, positive. 6, negative 8i, negative 3i combine, negative 11i. I squared is negative 1, right? This part is negative 1. Negative 1 times 4, negative 4. Combine again, 2 minus 11i over 25. And that's good enough for me. But if you want, you can rewrite that in the standard form. Remember, left ear over the head, 2 over 25. Right ear over the head, minus 11 over 25i. This way, you can see the real part and the imaginary part clearly. So you can see, this is not a coincidence. Generally true. You divide a complex number by a complex number, you have a complex number as the quotient. One more. One more is one example in my note. Negative 8 over 5i. Okay, you can see that as negative 8 on the top, 5i on the bottom. Anyway, we have I in the denominator. Remember I mentioned earlier, If we have I in the denominator, then the expression is not seen as simplified. We have to simplify it. Let's apply the 2 steps. Step 1, find the conjugate of 5i, the denominator. If we rewrite 5i in the standard form, we have 0 plus 5i, right? And the conjugate is supposed to be 0 minus 5i. Then we're supposed to multiply both top and bottom by negative 5i. However, this is a special case. This is a special case. We don't even have to multiply negative 5i, which is the conjugate of the denominator. All that we need to do is to multiply both top and bottom by I only. You would have the same thing. I mean, what's the purpose? You multiply by the conjugate. The purpose you multiply the conjugate of the denominator because you know the denominator after that is going to be a real number without I. So the real purpose is to get rid of I. When we could get rid of I simply by multiplying I, we don't do extra. We don't have to do negative 5 to make it complicated. Yes, you could if you do that, but you have to simplify. You know what I'm saying? So if you can go from A to B like that, you don't go that. Okay, so we have negative, numerator is 8i, numerator is 8i, denominator is 5i squared. What is I squared again? Negative 1. So negative 1, negative cancel each other, you end up with 8i over 5. You see that? That is also a complex number because that is 0 plus 8 over 5 times I. Real part yellow, imaginary part pink. Okay, all right, so that's everything about, I have more examples in the notes. You can use them as a practice. So that was everything about this section. We're supposed to cover that on Wednesday. For the other class is Monday evening. Yeah, so we covered the concept of complex number, and we also covered how do we plus, minus, multiply, and divide complex numbers.